sample problem solvings today regarding ideal gas law. And then tomorrow, we'll discuss a little bit yung specific heat and then problem solving afterwards. And then we can have an early dismissal tomorrow for you to prepare dun sa quiz. Tapos, next week, so face-to-face, we'll have our first quiz. So, that will be for 1.5 hours. So, good for 1.5 hours yung quiz. So, study. So, again, the scope will be from the beginning until the first law of thermodynamics. So, ideal gas law ay hindi pa not part of the quiz. And then, I'm thinking if yung problem set ay para makabawas din sa load nyo is yung notebook nyo. That's why I'm pushing everyone to do yung problems on your notebook. So one of these days, siguro papapasa ko lang siya para lang ma-check ko ng mabilisan. And then isasoli ko lang din siya. Ganun. Ayun. Any questions? So today, we'll discuss may assignment ako no sa inyo. I have
Opo, ma'am.
correct. So I think 2 problems yun. So we'll discuss the solution for those 2 problems and then I'll just add 1 problem and then dismiss na tayo. So discuss ko lang yung solution for those problems. Okay? But I'll pick one para mag-solve noong problem natin. So I think, wait lang. Sample problem number 24, yung assignment, correct?
23 at 24 po.
23 and 24. Okay, so 4 problems pala tayo today because I still have 2 problems at the end of the slide. Ox. Let me just share my screen. So 23. Let me know if my screen is visible na. Okay. So this is sample problem number 23. So Mr. Tawag lang ako. Yung absent last week. Ay, wala. Ito na lang. Alan May. Last week. Yeah. Alan May Valdez.
Yes po, ma'am.
Can you please discuss your solution for sample problem number 23?
For tank 1 po, ang formula ay P1 B1 is equals to M1 RT1. So,
Oh, wait lang.
P1 B1 over
Wait for a
yung
while. Sorry to interrupt. Class, tama ba? Ito yung sample 23 nyo? Sample number...
Yung 2 tanks po yung yung sample number 23. Tapos 24 po yun.
Okay. Sige. Wait lang. Sorry. Eto. Nakalipat na ba yung screen? Hindi pa. Wait lang. Unshare lang ako. Ato, class.
Opo.
Okay. Sige, Miss Allen Valdez. Continue.
P1 B1 over our P1 is equals to 300 times 0.3 over 0.5182 times 273.15 plus 20. So, the answer po dun sa tank 1 ay 0.5925 kilogram. Then, sa tank 2 naman po ay M2 R22 over P2. So, 1.5 times 0.5182 times 273.15 plus 30 over 800. So, ang answer po dun sa tank 2 ay 0.2945 m cube. Then, the two tanks are in equilibrium at the final state. So, M3 is equals to M1 plus M2. So, ipagpa-plus lang po yung 0.5925 plus 1.5 is equals to 2.0925 kilogram po. Then, V3 is equals to B1 plus V2 is equals to 0.3 plus 0.2945 is equals to 0.5945 m cube. Then, ang formula naman pong gagamitin natin to find the equilibrium ay M cube, M3 RT3 over B3 is equals to 2.0925 times 0.5182 times 273.15 plus 25 over 0.5925 is equals to 543.8 kPa po.
Where did you get your M3? You missed to discuss. Alan May? Then the question is, where did you get your M3 or your mass in equilibrium? Alan May, can you hear me? Class, am I audible?
Opo.
Yes po, ma'am.
Okay, anyway, would like to ask everyone, is the solution clear or you want me to discuss the solution?
Discuss po.
Okay.
Yes po.
Alright. Sige, discuss natin, no? So in this problem, we have two tanks, tank 1 and tank 2. So the conditions and the parameters involved for tank 1 are, first, we have a temperature of 20 degrees Celsius, a pressure of 300 kilopascals, and the volume of the tank 1 is 0.3 cubic meters. And then we have the second tank having a temperature of 30 degrees Celsius, pressure of 800 kilopascals, and the mass of methane inside is 1.5 kilograms. So take note, class, that the substance present inside tank 1 and tank 2 are the same. No? So we have here the methane. Therefore, for the value of the gas constant, we are going to use the given gas constant, which is 0.5182 kilojoules per kilogram Kelvin. So, to solve, so we're given, oops, wala pala akong space to, wait lang class, mag-insert lang ako ng slide to insert yung magiging solution. Plus pag ganito ba, naglipat na siya sa different slide or sa inyo yung pa ring problem?
Yung problem pa rin po.
Okay. So, wait. Stop lang ulit ako. Pag ganito, okay na. Kita niyo na yung blank slide?
Opo.
Okay. So, wait lang. So in this problem again, we are given of the condition of both tanks. So given natin dito, we have for tank 1, volume is 0.3 cubic meters. T1 is 20 degrees Celsius. So class no, lagi always convert agad-agad yung temperature to the absolute temperature. So this is plus 273.15, and then our initial temperature or temperature for tank 1 is 293.15 Kelvin. And then we're also given of the pressure. This is pressure for tank 1 is 300 kilopascals. And then we're also given of the value of the gas constant, which is 0.5182 kilojoules per kilogram Kelvin. And then for tank 2, we're given of the mass of methane, which is 1.5 kilograms. We're also given of the temperature. This is tank 2. Tank 2. Yan. We're also given of the temperature 2. And the temperature 2 is 30 kilograms Celsius. So plus 273.15. We have 303.15 Kelvin. And then we're also given of the pressure sa tank 2, which is 800 kilopascals. And then, wait, we are asked to, and then we're also given of the temperature at equilibrium. So temperature at equilibrium which is equal to 25 degrees Celsius plus 273.15. So it is 298.15 Kelvin. Now, the first question or the first requirement is for us to find the equilibrium pressure. So we only have one requirement pala for this problem. So we're asked to find the equilibrium pressure for this problem given that the partition between the two tanks was removed. So para makuha natin siya, class, first is we need to get the mass of methane inside the first tank or the tank 1. So we have the formula for gas law. We'll use P1 V1 is equal to mass 1 or mass ng methane at tank 1 are T1. So, in order to get for the mass, so mass 1 will be equal to P1 V1 over R T1. So substituting the values, we have here P1 is 300 kilopascals. So again, i-convert ko na siya on the kilonewton per meter squared unit. V1 natin is 0.3 cubic meters. And then we have the value of R, 0.5182. Kilojoule is kilonewton meter over kilogram Kelvin times the temperature na 293.15 Kelvin. Okay, so let's cancel yung mga units mo na. So cancel na kilonewton. So in here, this is M, may matitirang isang M, no? But we also have meters sa baba, so cancel na rin siya. And then, makakancel na rin si Kelvin. So, our mass 1, what did you get, class?
0.592454772
7.
kilogram
Correct.
mass po.
So, this is 592454772 kilograms. And then, so, complete na yung, we have already the complete parameters for tank 1. So, we have P, V, M, R, and T. For tank 2 naman, we are given again of the mass, temperature, pressure, and the value of R. So, we will be able to get then the value for the volume. So, we will also use the formula for ideal gas law, no? Which is PVM 2R T2 to get for the value of volume. So in here, again, tank 2, we're given of the value of pressure. We also have the value of mass, we have the R, and then we also have the temperature. So formula to get the volume 2, this will be equal to M2 R T2 over P2. Okay? And then substitute lang. So this is just direct substitution. So value natin of the mass is 1.5 kilograms. And then we have the value of R, which is 0.5182 kilojoules. So kilonewton meter over kilogram Kelvin. This is R. And then our value of the temperature is 303.15 Kelvin. All over, the pressure at tank 2 is 800 kilonewton over m squared. Class, okay na tayo sa unit analysis ha? Dinadirect, ano ko na yung, binibreakdown ko na yung mga units to its equivalent unit na nakahiwalay yung, hindi siya nakakilopascal. So, na-convert ko na siya directly to kilonewton per meter squared yung kilopascal. And then yung kilojoule ay kilonewton times meter. So, I hope wala nang nalilito dito. Okay? So, cancel tayo ng units. So, cancel na si kilonewton, Kelvin, and then, ano pa? Kilograms, makakancel na rin. Wala na, no? So, solving for the value of volume, V2 is equivalent to 0.2945 48118. Did you also get the same value? for
Opo.
volume?
Yes.
Okay. So now class, we already have the mass for the first tank, the volume of the second tank. So bakit ba natin siya kinuha? Yeah. Mr. Billy, can you... Okay. Okay.
Nabuksan lang po, napindot lang po, sorry po.
Okay
Nag-ano
lang.
po.
It's okay. So let's now proceed to the equilibrium state of the two tanks. So again, the partition was removed. So it will take time now before the tank go to the equilibrium state. So since na-remove na yung partition class, so itong partition na to yung sinasabi. Since tinanggal na to, ang magiging volume na natin is yung total volume. Kumbaga, yung pinagsamang volume or the combined volume of both tanks. So that will be our new volume or the volume at equilibrium state. On the other hand, we will also get the mass at equilibrium state. So that will be the mass, the sum of both masses. So we have the mass for tank 1 and the mass for tank 2. So kailangan natin makuha sila both para masolve na natin yung pressure at the equilibrium state using this formula. So at equilibrium state, gagamitin natin pa rin yung formula ng gas law, which is PV-MRT. Yan. So we are already given of the temperature at equilibrium state, and then we have the value of the mass at tank 1, and then we're given of the mass at tank 2. So we will be able to get na the total mass dun sa combination of the two tanks. And then for the volume, same with mass. So we will be adding the volume of both tanks. So V3 will be equal to the volume of the first tank plus the volume of the second tank. So solving first for M3, so this will be M1 plus M2. So M1 natin, from what we solved earlier, it is equivalent to 0.592454,772 kilograms. And then, plus M2 natin is 1.5 kilograms. So M3 natin is 2.092454,772 kilograms. 7, kulang ako na isang 7, 772. So this is 2. Ayan. And then, solving naman for the volume, dito ko na i-continue sa kabila. Solving for the volume at equilibrium, so we'll just add the two volumes. So V1 plus V2, which is equal to 0.3. So galing do sa given, 0.3 cubic meters plus V2 is, from what we solved, is 0.2945 48118 cubic meters. So the volume at equilibrium, or the total volume of the tanks, is 0.594. This is 594 548,118. Okay, now since we already have V3 and R is given, we will now be able to solve the pressure at equilibrium. So, derive ko na no directly. So, P3 will be equal to M3 RT3 over V3. So, direct substitution na to. Our M3 is 2.09244772 kilograms times value natin ng R is 0.5182 kilojoule. This is kilonewton meter over kilogram Kelvin. And then value natin for the temperature at equilibrium is 298.15 Kelvin all over the total volume, which is 0.5945 594 548,118 cubic meters. So, what did you get? What's your pressure at equilibrium, class?
543.75247.6.
752,476.
Opo,
This
kilonewton.
is mag-unit analysis muna ulit tayo. Okay, so cancel na si kilograms. Kelvin will be cancelled as well. And then, mawala na yung isa dito. Magiging 2 na lang. Mawala na to. So, ang matitira natin, class, is kilonewton per meter squared. And again, this is equivalent to kilopascal. So, our final answer for this problem is 543.752 kilopascals. Okay? Clear, class? Okay. Oh, Mr. Valin, you're already here. Let me just... Okay, then we'll proceed to the next problem. So, Mr. Billy Simon, can you please discuss your solution for sample problem number 23? Gilly? Who wants to answer sample problem number 23, class?
Ma'am, ano po?
Okay, Dave.
Yung answer na po ba agad?
Discuss your solution.
Sige po. Given po is yung gas constant which is R po, 0.3 kilojoules over kilogram K. Gagawin ko na po agad yung kilonewton per meter over kilogram K. Tapos given din po yung pressure na 100 kilopascal. Ginawa ko na din pong 100 kilonewton per meter square over, oo nga pa. Tapos sa volume po, i-multiply lang po yung 10 meter times 10 meter times 9 meter. Magiging 900 meter cube po. Tapos yung temperature po na 27 degrees Celsius, gagawin na pong absolute temperature, magiging 300.15 Kelvin po. Tapos ang hinahanap po ay mass of air. Ang ginamit ko pong formula ay PV equals to MRT. Tapos yung M, derive po yung formula for mass, which is M is equals to PV over RT. Tapos substitute lang po yung mga given. Mass is equals to 100 kilonewton over meter square multiplied to 900 meter cube all over 0.3 kilonewton meter per kilogram K multiplied to 300.15 K, magiging sagot po ay 999.500 kilogram. Tapos final answer po is 999.500 kilogram.
Okay, very good. I think that is already a clear explanation of the solution. Any questions from the class? Did you also get the same answer? Okay, so hindi ko na siya i-discuss, no? Adham, how about you? Did you get the same answer?
Yes, ma'am.
Alright. So everything clear for sample problem number 23. We'll now proceed to our additional problems. So this will be 3 problems pa pala, no? So we will have sample problem 24, 25, and 26. Okay. Sample problem 24. So during a steady flow process, the pressure of the working substance drops from 200 to 20 psie. So this is absolute pressure. The speed increases from 200 to 1000 feet per second. The internal energy of the open system decreases 25 BTU per pound, and the specific volume increases from 1 to 8 cubic foot per pound. No heat is transferred. So first is sketch an energy diagram. Second requirement is determine the work per pound. So this is pound mass class. This is determine the work per pound mass. Is it done on or by the substance? And then the last requirement is we're required to determine the work in horsepower or HP for 10 pound mass per minute na mass flow rate. So, given tayo ng conversion, which is 1 HP is equal to 42.4 BTU per minute. So, i-discuss ko na lang class, no? So, in this problem, given. Let's write all the given data. So, this is a steady flow process. We're given of the pressure. Pressure of the working substance drops from, so this is your 1 initial, and then ito yung 2. Kumbaga ito yung naging pressure niya after the change or after the process. So we have here P1 and P2. So our P1 or pressure 1 or initial pressure is 200 psia. P2 is 20 psia. The speed increases, so we have here the velocity. The Martin V is equal to 200 feet per second, so that's FPS. And then the Martin V or the final velocity, so the speed increases now. The final speed is 1000 feet per second. And then it was stated that the internal energy of the open system decreases. So meaning we have the internal energy. So this is delta. Delta U of the system decreases. So this is class negative 25 BTU per pound. So this is a specific internal energy. Again, class, no, as I discussed during our previous discussions, when you are given of a quantity or a value that is specific, so expect that your unit will be per mass or per unit mass. So it could be BTU per, this is BTU per pound mass. So this could be also kilojoule per kilogram mass, ganyan. Are we clear on that? So this is a change in specific internal energy of the system since we are given of per unit mass value of energy. Clear?
Clear po.
Okay. And then specific volume increases from 1. So this is V na maliit, 1. So initial specific volume is 1 cubic foot per pound mass, and then our final specific volume is 8 cubic foot per pound mass. It was also stated that no heat is transferred, meaning our Q is 0. First is we're asked to sketch the energy diagram. So energy diagram class, ipapakita nyo lang that you have your system. Or your substance. And then, i-assess natin what forms of energy are involved in this problem. So since we're given of the pressure, which form of energy is pressure involved in the calculation class? Which form of energy are we using pressure? Formula? Anyone? If we are given ng elevation, of course, there is a potential energy. But if we are given of a pressure, then what form of energy is present?
Try lang po ma'am. Workflow po.
Correct. So that's workflow or flow work, no? So class, tatandaan to. If you're given ng pressure, ginagamit yan sa flow work. If you're given of a velocity, ginagamit to saan? Correct, kinetic energy. And if you're given of a height or elevation, sometimes it is denoted by letter Z. You have what kind of energy or what form of energy? You have potential energy. Tatandaan class ha. Again, if you're given ng pressure, for sure there is workflow or flow work na nangyari or na present on your system. Okay, so we have pressure. So we have here flow work 1 entering. Meron ding lumabas since we're given of the final pressure. Ano pa? We're also given of the velocity. So again, if you have a velocity, you have a kinetic energy. So meron tayong leaving the system. What else? Meron pa ba? Internal energy. And we also have, since wala tayong heat transfer, hindi na natin siya ilalagay. And we also have the work, no? However, for work, hindi natin sure if yung work is done on the system or done by the system. Di pa natin alam yan. But we need to include work in our energy diagram. Okay? So let's have the formula or the equation given the energy diagram. So um, ano yung mga magiging equation natin? What will be our equation? So we'll have here energy entering R. We have workflow 1 or flow work 1 plus kinetic energy 1 plus internal energy 1. Sa kabila ko na ilalagay si work since 'di ba, ano general equation work is on the right side of the equation kasi we are assuming that the work is being done by the system. However, later we'll know if tama ba yung assumption natin. So, in our assumption, work is being done by the system. So, nasa energy leaving siya. So, this will be our assumption again. This will be our assumption. So, we have here the work plus, ano pa yung mga nag-leave sa system? We have workflow work 2. We have KE2. And lastly, we have the internal energy. However, class, again, we're given already of the delta U. Why? Because it was stated in the problem that the internal energy of the system decreases 25 BTU per pound. So, meaning, yung binigay sa atin na ito is already the U2 minus U1. So, let's simplify further this equation. So, ita-transpose na natin sa right side of the equation just to get the delta values. So, wala nang matitira sa left side of the equation since all of these three initial energies will be transferred to the right side. So, we have here flow work 2 minus flow work 1 plus KE2 minus KE1 and then U2 minus U1. So our work will be delta workflow plus delta KE plus delta U. And again, class, ito na yung given natin sa problem, the delta U. Okay? Now, isa-isahin natin yung mga requirement since we're given of these parameters or data. So, ayan. So, we have this data. Let's solve first for the kinetic energy. So, since class, kung mapapansin nyo, we are given of the change in internal energy na specific. So, we'll proceed with the solution na naka-specific din siya or per unit mass. So, first, in solving for the kinetic energy, so again, this is per unit mass. In this case, since we are in English system, so this is per pound mass. Clear ba dun, class? Meaning, all of our formula involving mass, tatanggalin natin yung mass so that our equation or our answer for that form of energy will be per unit mass. Example, if your formula for Ke is 1/2 mv squared, since we're talking about per unit mass, alisin na natin muna yung m sa equation. So, same with example, we are solving for the potential energy. So, if per unit mass yung gagamitin natin, then we'll just remove the mass in the equation. But your answer here will be either kilojoule per kilogram, or in English, it could be a pound-foot per pound mass. So, this is force. Pwedeng ganito yung magiging sagot natin on our equation. Clear, class? Nakukuha pa? Nakakahabol pa lahat? Okay. So, solving for the first or sa KE1, sa initial kinetic energy natin, so this is per unit mass again. Our formula will be mv squared. So, magiging v squared na lang siya. So, this is initial velocity squared over 2. And will also include the proportionality constant. What's our proportionality constant in English? Class. What's the proportionality constant in English? Huwag kakalimutan to. Correct. And in English, sorry, in metric, what's our proportionality constant? Kilogram meter, or this is Newton? This is one kilogram mass, kilogram meter over Newton second squared. So, tatandaan yan, class. So, in this case, our initial volume is, initial velocity is 200 feet per second. This will be squared over 2 times proportionality constant na 32.2 pound. This is 32.2. Sorry, this is pound mass. Sa baba yung pound force. So, this is mass over force. So, this is pound mass foot over pound force second squared. Ayan. So, let's do the unit. So, this will be feet squared over second squared. So, mawawala na yung second squared. Yung feet, mawawala yung isa. So, may isa pa tayong feet sa taas. So, our answer here for the initial kinetic energy is what's your answer, class?
621.118012 po.
42236. So, ano yung magiging unit nito? So, this will be pound force times feet per pound mass. Ito yung sinasabi ko, class, no? Since we're solving for energy per unit mass, you will have a per pound mass sa denominator ng unit mo. Okay? Next, K ito tayo. So, same, no? Same formula. This will be final velocity squared over 2K. So, our final velocity is 1,000. 1,000 feet per second squared over 2 times 32.2. Pound mass feet per pound force second squared. So your kinetic energy, final kinetic energy is, this is 1,527.950310559001 pound force feet over pound mass. Okay, next ay okay na tayo dito. Sorry. Okay na tayo sa given na velocity. Let's now proceed dun sa paggagamitan ng pressure. So, again, flow work, no? So, our formula is, so flow work 1. So, this will also lead to upper unit mass unit of energy. So, this is P1 V1. So, this is a specific volume. Any question, class, kung bakit ito naging specific volume? Ito is maliit na V. Alam po ng lahat bakit to naging specific volume? Ma'am, yun po kasi yung given. Ganun ba yon? So, explain ko lang no for those na baka nalilito. 'Di ba, workflow natin is pressure times volume. However, since we are solving for for an energy per unit mass, 'di ba, we have volume over mass. And what is this? This is formula for specific volume. Correct? The maliit na V. This is the reciprocal of density. Diba? This is a reciprocal of density and our density is mass over volume. Kaya to naging pressure times specific volume. Clear po? Okay. So let's substitute the values. So this will be 200 PSIA. So PSI is pound per inches squared. Let's convert to feet. So we have 12 inches per feet squared times the specific volume. Initial specific volume is 1 cubic foot per pound mass. So let's cancel. So this will be feet squared. So makakancel na siya lahat, yung feet squared natin. Mawala na rin yung inches squared. Since dalawa yung nawala dito, may isa lang na matitira. This is class, I forgot to write. Since this is pressure, this is pound force. Okay? Para hindi, baka kasi po makancel nyo during solving. So this will be equal to 200 times 12 squared is what?
28,800 po.
28,800 and our unit will be pound force times feet over pound mass. So, lagi class ilalagay no, yung subscript if siya ay force or mass. Kasi in this case, kung hindi nyo siya nalagay ay baka makancel nyo yung pound. Clear po? Again, pressure natin is force over area. Kaya yung pound doon ay force. Clear?
Clear po.
Okay. Next, let's solve for the second or the final flow work. So this will be P2, maliit na V2. So P2 natin is 20 pound force inches squared times, convert natin din, 1 foot squared. And our final specific volume is 8 cubic foot per pound mass. And our final flow work is 23. Correct ba? 0.4. Yes, and our unit will be, so cancel na yung inches squared, makakancel din yung feet squared dito, may matitirang feet sa taas. So this will be pound force times feet over pound mass. Okay, now balik tayo dun sa ating equation dito. Or dito na lang para direct substitute natin dito. So, ika-copy ko lang class. So, di ba meron tayong 0, workflow 2 minus workflow 1 plus KE 2 minus KE 1 plus delta U natin plus work. So, substitute lang natin. Workflow 2 natin is 23,040 pound force times feet per pound mass minus, tama pala, 28,800 pound force feet per pound mass plus kinetic energy natin final is 15527, 9503, 1055, 901 pound over pound mass minus initial kinetic energy natin is 621,118,012,42236 pound force foot over pound mass. Internal energy natin is 25 BTU per pound mass. And ano yung conversion natin? 1 BTU ay ilang pound foot po? Class conversion. Open your notebook. 77?
8
4
po.
correct. 778. This is pound foot plus the work. So, simplify muna natin. 23,040 minus 28800. 23,040 minus 28,800 class. Hello?
Negative 5,760 po.
Pound. Next, ito naman. Plus 15527 minus 621. Hello?
14,906.8323 po.
Ano pa yung kasunod dito? 8323.
Ah,
Sige. $25 times 778. This is pound foot. Zero is equal to, ano yung, makikisimplify po nitong tatlo. Is nakuha din?
Opo.
Okay. And then, our work will be, i-ano ko na dito sa taas class. Ito na lang. Ituloy ko na lang dito. So, transpose lang natin siya sa kabila. So, our work will be 10, 303, ko ito. 10,303, 16,770, 186,335 pound foot over pound mass. So, ito na yung kinukuha sa first requirement natin. So, this is the work per pound. Okay? So, answer here will be 10,303, 168. pound force foot per pound mass. Or in BTU, can someone divide this to 778?
Thirteen point 243 po.
BTU per pound mass. So, ito po yung hinahanap sa ating problem. So, sasabihin ko naman sa exam if ano yung magiging unit ng final answer. Okay, next requirement. So, is it done on or by the substance? Since ang nakuha natin na sagot is positive, then if your work is positive, is it done by the system or done on the system?
By the
Done by
system.
Correct. So, this is done by the system. So, tama yung ating assumption, done by the system. Next naman, determine the work in HP for 10 pound mass per minute. So, we are given of the flow rate. So, pagkakasyahin ko na siya dito. Work in HP. Ibahin ko na lang yung kulay. So, work in HP natin, since we're given ng flow rate, so this is pound mass per minute. So, i-multiply lang natin siya, So, that will be, kahit dito na, 13.243,146,14635. So, this is BTU per pound mass times, given tayo ng 10 pound per minute. So, this is 10 pound mass per minute. Multiply lang sa 10. So, this will be 132.43,146,14635. Cancel na yung pound mass. This is BTU per minute. And given tayo ng 42.4 BTU per minute per HP. So, 1 HP over 42.4 BTU per minute. So, our work in HP is equal to
3.1238.
3.12338 352,508 352,508 HP. Or in 3 decimal places, this is 123 HP. So this is your final answer. Clear, class? May tanong? Nasundan, even the units? Alam ko ano nangyayari sa units? Again ha, watch out class yung pound force and pound mass. Baka kasi makancel nyo siya during your solution. So, watch out yun, no? If we're talking about pressure, so pound force yun. If we're talking about mga specific volume, o kaya mass flow rate, so that is pound mass in English. Okay? And then, so if wala nang question, proceed tayo sa next problem. So this is easy. Steam enters a turbine with an enthalpy of 1,292 BTU per pound and leaves with an enthalpy of 1,098 BTU per pound. The transferred heat is 13 BTU per pound. What is the work in BTU per minute and in HP for a flow of 2 pound per second? So, lista natin lahat ng given. enthalpy. So this is our enthalpy 1. Ito yung nag-enter sa system. This is our H2. So ito yung lumabas sa system natin. The transferred heat is 13 BTU per pound. So ano kaya to? Anyone from the class? Make a wise guess. The transferred heat is 13 BTU per pound. Is it entering the system or is it leaving the system? Entering or... Sige, mamaya makikita natin. And we're asked of the work in BTU per minute and in HP for a flow of 2 pound per second. What is this class? Help ko kayo mag-analyze ng problem para pag solution ay madali na. What is this 2 pound per second? Class? What is 2 pound per second here? Volume flow rate ba yan? Mass flow rate? Pressure ba yan? Temperature? Volume? Velocity ba yan? Okay. So, class remember, no? Again, if you are given ng, ano ba to? This is pound mass. So, this is mass flow rate. Magiging volume flow rate siya, class, if your numerator ng unit mo is a volume unit. So, if you are given ng, halimbawa, cubic foot per second or cubic foot per minute, or pwede rin na you're given ng gallons per minute, this is the volume flow rate. However, if you are given ng, let's say, slug, ito yung mga unit ng mass, pwedeng slug per second, o kaya pwede ring pound mass per second. So, this is mass flow rate. Clear ba tayo, class? Para pag nagsosolve kayo, just looking at the unit, alam niyo na yung magiging operation nyo kahit hindi nyo sa ulo yung formula. Sometimes, class, yung unit yung makaka-help sa atin to solve a problem. Yung unit analysis. There are many problems na ma-encounter kayo na kahit hindi nyo alam yung formula. However, just by doing the unit analysis, you can already solve the problem. Again, so 2 pound per second is a mass flow rate, class, no? This is a mass flow rate. Clear tayo doon? Again, if you are given ng foot, ng mga volume, unit ng volume, kahit pa yun ay inches cube per minute, kung ano man liters per minute, so yun yung volume flow rate. Pag mass flow rate naman, ay di mass, unit of mass yung nasa numerator. Okay, class? Clear tayo doon. Wala nang malilito sa mga flow rate.
Clear po.
Okay. So, let's solve this problem. So, we have a we have a turbine. So, wala namang na-mention dito na mga elevation, wala namang na-mention dito na mga velocity, So, if we're doing the energy diagram, ang pumasok lang, or the energy that entered the system is enthalpy. And the energy that leave the system is enthalpy din. However, given tayo ng the transferred heat which is 13 BTU per pound. So dito siguro yung iba dito malilito, ano ba yung transferred heat? Is it the heat transferred from the surroundings to the system or from the system to the surroundings? So ito, class, since we're talking about the steam, remember, no, sa isang turbine, class, ang pumapasok dyan ay high pressure, high temperature na steam. So, lagi na meron kang turbine and the steam that entered the turbine is a high pressure, high temperature steam. Lagi yan nagkakaroon ka ng loss sa iyong heat. Tatandaan yun. Kasi yung energy from the steam ay mako-convert into different form of energy. So that's the purpose of steam in a turbine. Siya yung kumbaga nagpo-provide ng energy. So if your steam entered the turbine at a high pressure, high temperature state, therefore, yung heat transferred is from the steam. Yan. Again, your heat transferred is yung from the steam. Steam yung nag-provide ng heat. So, let's solve this. Since we are only given ng enthalpy, so, ang magiging energy balance lang natin dito is Q equals W plus delta H. And then, ang pinapahanap sa atin is yung work in BTU per minute. So, analyze natin. Since yung steam nyo class is yun yung nag-provide ng energy or yun yung kumbaga na-convert yung energy niya into other forms of energy, yung heat na to ay magiging negative. So, this is yung nag-lose ng heat yung steam nyo. So, this is negative 13 BTU per pound mass. Ang work natin yung hinahanap. So, this is work plus change in enthalpy. So, H2 minus H1. So, negative 13. So, this is negative 13 BTU per pound mass is equal to work plus H2 natin is 1,098 BTU per pound mass minus 1,292 BTU per pound mass. This is pound mass. So 1,098 minus 1,292. Class?
Negative 194 po.
So this will be so solving for work. So work will be transposed sa kabila to negative 13 BTU per pound mass plus 194 BTU per pound mass. So your work will be
181 po BTU per pound mass.
181 BTU per pound mass. And then we're given class of the flow, which is 2 pound per second. So again, your mass flow rate is 2 pound per second. However, ang hinahanap sa atin is work in BTU. So, i-multiply na natin to sa 60 second per minute. So, meaning, our new mass flow rate is 120 pound mass per minute. So, times lang natin dito. 120 pound mass per minute. This is equal to
21,720 po.
21,720, cancel na yung pound mass. This is the work in BTU per minute. So, ito na yung sagot natin dito sa unang requirement. Next ay hinahanapan tayo ng work in HP naman. So, that will be 21,720 BTU per minute times 1 HP is equivalent to how many BTU per minute?
42.4 po.
42.4 BTU per minute. So, our work is in HP is
512.2641509 HP po.
or in final answer natin here is 512,264 HP. Okay? Clear ba, class? Okay. So, yung next problem ay kayo na lang ang mag-solve. But the answer here is for letter A, ang mass used or proportion of acetylene used is 0.13906585815 pounds or pound mass. Sa letter B naman is ang volume ay 2.10549966357 cubic feet. If hindi ma-solve, ask sa kaklase. If hindi pa rin kaya ni kaklase, ask me. Okay? But this is your assignment. This problem is also, or you can also see this problem in the Hipólito book. Alright. So, again, next week will be your first quiz. Study well and good luck. Yun lang, class, for today. Any questions or concerns? Yes, Mr. Jose.
Good morning po, ma'am. Na-late lang po ako dahil po nagkaka-problem po yung PLDT.
Rico. Okay. Internet connection problem. Other concerns, class? Practice solving na. If wala
Ma'am,
na,
excuse po. Pwede
yes,
pong pabalik sa previous problem po.
sure.
Mag-i-screenshot lang po.
Okay. Wait lang. Ito?
Yes po. Salamat po.
Okay, if wala nang tanong or concerns, class, dismiss na tayo. Thank you, everyone. Study hard.
Thank you.
po.
Thank you.
Thank you po.
Thank you po.